Yo, what's up? I hope you're having an amazing day. Recently, I picked up one of these bad boys from a garage sale. If you don't know what this is an Etch-A-Sketch, and you can basically illustrate onto the panel in the front using these two knobs at the bottom, and it's pretty cool, but it's also very difficult. And while I'm an amazing engineer and funny and humble, I'm not very great at it. So I'm going to make an automatic Etch-A-Sketcher that draws for me. I already went ahead and ordered some motor drivers and motors to control the knobs at the bottom, and they're coming in tomorrow morning. Until then, I'm not really going to do much because I think if I start CADing without having the motor sitting in front of me, I'm going to do stuff wrong and have to reprint. And I don't want that. I don't want to have to waste a bunch of filament. So we'll just wait until tomorrow morning. I will see you then. Hello, it is VoiceOver Jet here. In this order, I just got some NEMA 17 stepper motors and compatible stepper motor drivers. I can go ahead and throw the specs on the screen now. The stepper motors are for controlling the knobs on the Etch-A-Sketch and are luckily the only electronics I'll have to be dealing with for the most part. I'm not sure what it is about these stepper motors, but they make me feel so professional and engineering. It could be because they're shiny, I'm not sure. This morning, I'm just going to try to get the stepper motor working with the motor driver. If I can do that, it's a good day. It didn't take too long to get the stepper motor driver to work with the stepper motor. I should have put some sort of tape around the stepper motor thingy so you could see that it's actually turning. I don't know how well it is evident in this clip, but yeah, I got it to work, so that was exciting. Now that I had the stepper motors and the stepper motor drivers in, but more specifically the stepper motors, I could begin CADing and design a system of integrating the motors onto the Etch-A-Sketch. This also took much less time than I thought it would, and now that I'm editing the video, I haven't CADed in a while and I really miss it because it's really fun. I'm back at my apartment for the day and I have all of the prints that I plan on doing done. I'm pretty happy with how they came out. This is one of the sides of my Etch-A-Sketch mechanism. This is what the Etch-A-Sketch now looks like. Why am I holding it like that? I glued on the motor cases to the 3D printed frame that I built and then just made some gears that could attach them to the knobs of the Etch-A-Sketch and to the servo motors. Before I could get totally started, I had to set the current limits for the drivers to make sure I was operating the motor safely and preventing overheating. It was a pretty easy process and I found out how to do it from the motor website. So shout out the motor website. And now I could finally get started testing the stepper motor Etch-A-Sketch mechanism. And here's a quick clip of it writing happy birthday using parametric equations. Yo, this is Jet, like 6 weeks in the future. Hey Jet, why are you 6 weeks in the future? Don't worry, I'll touch on that a little later in the video. Right now, what I want to talk about is code. I needed a way to turn images into Etch-A-Sketchable things. Kind of like how a slicing software turns 3D geometries into slices that a 3D printer can understand. Now to do this, I had to establish the bounds of the Etch-A-Sketch. 1, it draws things in one line. That's kind of like the whole idea behind an Etch-A-Sketch. You just draw and you can't pick up the line. If you want to erase, you have to shake it, but then it erases the whole image. So that's not an option. And the second bound, which isn't really that much of a bound, but I guess it is that there's two knobs, and that's how you actually control it. There's an X knob and there's a Y knob. The second one is easy because any 2D geometry can be represented by X and Y coordinates. But the first bound, drawing an image in one line, is the interesting part. I decided to go about it in the most simple way that I could think of. First, I resized the image to be the same resolution as the Etch-A-Sketch. To find this resolution, I just found the length of the X and Y in terms of steps in the stepper motor. Then using the great library of OpenCV, I could convert the image to black and white and then find all of the largest pixel clusters within the image. I even added a slide for the threshold value in the black and white conversion to make images more Etch-A-Sketchable. Because some images, if you just set them at the basic like 50% threshold, look wrong and just don't really make sense in an Etch-A-Sketch. So you have to change that threshold value. And then I found all of the largest pixel clusters in the image because those are the things that I'm actually going to etch into the sketch, the canvas. I wish the name was a little bit less syllables because I'm saying it so much. Anyways, now I had to find a way to traverse these pixel clusters in a single path because on the Etch-A-Sketch, images are drawn in a single path. To do this, I set up an iterative DFS or depth first search algorithm. I did first try a recursive DFS algorithm, but it overflowed because it was just too much to recurse through. To describe the DFS algorithm simply, I started in the first pixel of the pixel cluster and I looked left, right, up, down. I looked around my pixel and I saw if any pixels around me satisfied two conditions. The first condition being if the pixel is in the pixel cluster, and the second condition is if the pixel had been visited before in the path. If those conditions are true, I go on to the pixel. But there is a circumstance where I may want to go to a visited pixel. If all the pixels around me have been visited, and I know there are still pixels in the cluster that I need to get to finish drawing it out, then and only then can I move on to a pixel that has already been visited. Again, under no circumstances am I going to a pixel that isn't in the cluster. Once I finish the cluster, I move on to the next cluster and then to the next cluster, and I do this until I drew all of the clusters in the image. Now, how do I actually send the path to the stepper motors to move the cursor on the Etch-A-Sketch? The path is described with coordinates, so I iterate through the path and I send each individual coordinate to the Arduino, which I'm using to control the stepper motors. And the Arduino compares the previous coordinate that's been sent to the current one and then sees how much it needs to move to reach the new coordinate. An extra thing that I added for accessibility and quicker testing is a computer simulated model of like traversing the path or what the Etch-A-Sketch should be drawing. It is never one-to-one with the Etch-A-Sketch because it is much more accurate on a perfect simulated system than an Etch-A-Sketch. But it did make testing for the pathfinding algorithm much faster, which was amazing. Also, very quickly, I am moving out of this apartment. I know, it's so sad. Anyway, I think that's everything for the code and stuff. As you can see, I am not in the apartment anymore. I'm back home, finished moving out, and it's taking me a little bit longer to finish this project, this whole ordeal, than expected because, well, I had to box everything up and then unbox everything and still plan out how I was going to actually finish this video. I'm happy to say that I am finished with the project. I finished it weeks ago before I even moved. I just never had the chance to properly document it. I'll go ahead and throw on the screen a time lapse of the Mona Lisa being etched by my Etch-A-Sketch. It isn't perfect, but it is the best attempt at such a complex, like solid drawing that I've seen, so I'm pretty happy with it. I have drawn some other things with it, but really the hardest part is finding images that can be well drawn by the Etch-A-Sketch because a lot of images just don't really convert well, or you can't really tell what it is. It drew a cat. I might have a picture of it on the screen. I don't know where it went. When I showed it to my friends, they couldn't tell it was a cat, which is fair because you can't really tell it's a cat unless you already know what you're looking at. But either way, I'm really happy with how this project came out. Now, really quickly, I want to talk about the issues that I ran into on this project because no project exists without issues. There were really only two issues with the project. One of them just being a complete mistake is when I first started the project, I didn't want the motors going really fast because it could break if I had code implemented incorrectly. So I put some delays down in like the individual step commands that I was sending through the microcontroller. Now I forgot that these delays were put inside of this code. And so I went ahead and coded the entire project and went to start testing it. And it was really slow. It would take hours to do small drawings. And I thought this made no sense because stepper motors are the same motors they use in like 3D printers and whatnot. And 3D printers can be pretty fast if you've seen like bamboo printers. I just thought that the motors were slow and I didn't think too much into it. And I went ahead and made that simulator on my computer to test faster. And it wasn't until about when I finished the project I found the delays, and it made it so much faster to test on like the actual hardware rather than just using it in the simulator, because the simulator only works for pathfinding. It didn't really help for the stepper motor issues that I was running into. Now, the second detrimental issue that I ran into were how the gears between the stepper motors and the knobs on the Etch-A-Sketch were interacting. Whenever I went from counterclockwise to clockwise or vice versa, the teeth on the gears would have to re-catch in order to actually interact with the knob. It did take me a while to spot, however, because I was so confident in my hardware because it clipped on first try and it seemed to be working first try that I never thought to go back to it. I was focusing primarily on the code. But that's why we love code, because I could then fix it on software and not have to worry about reprinting anything. Other than that, my only issues with this project were time management issues because I was working 2 jobs and they were at very weird hours. Night shift at Wingstop is no joke, but oh my gosh, I'm addicted to Korean barbecue wings now. Anyways, that's really about it with the project. If you have any questions, feel free to drop them down below. I'd be so happy to answer them. I know I didn't cover everything perfectly in this. My train of thought or my creative plan was kind of dismantled as I took way longer than I expected on this project. So I must have missed some things. Please drop them in the comments if you have any of those questions. I would also like to add that the semester is about to begin and I will be very busy and I will most likely not be posting. And if I do, there will be different type of videos, most likely no more project videos. So please show this video some love. It's going to be the last one for a while. That's all for today. Thank you so much for watching, and as always, stay curious.